Hello and welcome to Mark's Tech Talk. In this edition, we're going to be talking about Bluetooth technology. Bluetooth was a wireless alternative to a way of connecting peripherals to a computer by way of RS-232. Some of you may be familiar with that. And Bluetooth was a wireless alternative to 232. It was actually named after a king of Denmark from the 10th century, and he was known for bringing together feuding parties, different families and so forth that were fighting. He would kind of bring them together and kind of bring peace. And the idea is with Bluetooth, you can connect different kinds of devices together. So this joining and bringing together is why they look to this particular king. And he was nicknamed Bluetooth, possibly, and I'm not really sure of this, but possibly because he may have had a tooth that was bad, and of course they had not very good dentistry at all at that point. That was 10th century. And apparently the tooth was very prominent and actually turned blue. So he got the nickname Bluetooth, and therefore we actually named this standard, if you will, after him. This was actually put on the market in 1999 with the first consumer device. And the standard originally was a standard that came under the IEEE. IEEE is an organization that does a lot of standards. They're Institute of Electrical and Electronic Engineers. But later, this was kind of handed off to what's called the Bluetooth Special Interest Group, which is a coalition of about 35,000 companies that utilize this technology, and they collectively just agree on a standard that they all can use, and it's no longer under IEEE anymore. The Bluetooth standard, as it exists right now, operates, and as a matter of fact, it always has operated, in what's called the ISM band. ISM stands for Industrial, Scientific, and Medical, and this is a band up in a range of 2.4 gigahertz. And within that band, there are 79 channels that Bluetooth operates on. And Bluetooth operates using what's called spread spectrum technology. And this is a rather interesting technology. This is where you start out communicating on one channel and then switch to a different channel and then switch to another channel and switch to another channel. And you do this in a pseudo-random fashion. Now, what do we mean by pseudo-random? Well, a pseudo-random sequence, let's say, for example, you only had 10 channels to deal with. You can create a pseudo-random sequence by taking some number that has non-repeating decimals. Let's say you have square root of 2. That's 1.414213 and so forth. Well, you may lop off the first couple digits and start using the 14213. So if you did that, you'd start communicating on channel 1, and then you'd switch to channel 4, and then 2, and then 1, and then 3, and then 5, and then 6, and then 2, and so forth. So it looks like you're changing channels randomly, but it is not exactly random. It's something that can be duplicated. So that's why it's called pseudo-random. And with Bluetooth technology, this channel switching occurs 1,600 times per second. And that really is interesting because although there are only 79 channels allocated to Bluetooth within this band, you can actually have more than 79 communications channels open simultaneously, and they don't interfere with one another because of this channel hopping, this spread spectrum technology. It allows for more users than you have channels. Really interesting technology. Bluetooth devices are classified by the power output of their transmitter. And class 1 is the highest power and has the largest range, 100 meters. That's used for industrial applications primarily. Class 2 is 10 meters. That's 2.5 milliwatt power. That's the most common. That's what most devices are. Then there's a class 3, which only has a 1 meter range. That might be something for your headphones to pair with your cell phone or something like that. And then more recently, they've come out with a class 4, which is half a milliwatt for even a shorter range. And they also introduced a 10 milliwatt, and that kind of fell between the 1 and 2, so they call it 1.5. So these are the classes as they exist today. There are 5 different classes: 1, 1.5, 2, 3, and 4. In addition to the classes of Bluetooth that are rated by power output, there are also versions of Bluetooth. The original, of course, is called 1.0. That used a FM modulation scheme, frequency modulation. And then they revised that. They came up with 2.0. And then at that point, they switched to phase modulation. And they were able to increase the data rate. And of course, that followed suit. Every time they changed versions of Bluetooth, they were able to get a higher data rate. So 3 operates also with phase modulation. Matter of fact, all the more recent ones are phase modulation. 3.0 is sometimes used in conjunction with Wi-Fi. So the communication actually occurs over a Wi-Fi channel and a Bluetooth channel simultaneously. Version 4 incorporated what's called low energy, and essentially what they're doing there is only turning it on when they're transmitting. Instead of having the transmitter turned on all the time, they only turn on when they need to, and they're able to save power that way. 4.0 was actually not widely adopted, but 4.2, which was a slight variation of 4.0, was widely adopted, and that also had the low energy scheme. There is a newer version that is out more recently. It's called 5.0, and this is interesting because it allows for a greater range, up to 350 meters, and that's possible because they have changed the way they modulate to a more reliable methodology, but that involves a slower data rate. So in order to get these greater ranges, they have to slow down the data speed, but that's obviously done automatically, invisible to the user. But kind of an interesting variation that they've come up with. The Bluetooth, as we mentioned, is at 2.4 gigahertz. That operates in what's called quasi line of sight, which is line of sight with a little caveat. There's a lot of reflection and refraction going on, so there could be obstacles between the two devices, and the Bluetooth will still operate because it will reflect off of walls or other surfaces and so on and so forth. So that's a quasi line of sight. The actual connections with Bluetooth, there are up to 7 simultaneous connections. That would be one master talking to 7 different slaves. And those 7 connections with that one master and 7 slaves are called a piconet. And within that piconet, the master unit controls the timing of the communication between the devices. And all this timing is divided up into time intervals called slots. And the way the communication works is the master transmits during the even slots, and the slaves transmit during odd slots. Now, interesting aspect of this is the master and slave may actually switch roles, and this occurs quite often when you're first pairing up a device. In other words, if you turn on a set of headphones, the headphones, when you first turn on, will act as the master and find, for example, your cell phone in order to listen to music. And once it pairs with the cell phone, then the cell phone becomes the master and the headphones revert back to a slave role. There's another possibility too. A master can simultaneously act as a slave to another Pico network. So if you want to have a connection between 2 PicoNets, one of the masters acts as a slave to the master in the other PicoNet. And when you join these 2 PicoNets together, that's called a scatter net. So just some terminology you may run across. Another interesting aspect of Bluetooth was the fact that it was invented by Heidi Lamar. Heidi Lamar was a Hollywood actress, and in the 1940s she came up with this idea of spread spectrum. And she, very, very well-known actress. She was actually dubbed as, by some people at the time as being the most beautiful woman in the world. And it was not somebody we typically envision as being a technology type of person, but she invented this technology which was then adopted by the military. And spread spectrum technology, because it keeps switching between channels, is very, very valuable to the military because it makes it very, very difficult to intercept the communication. Matter of fact, not only is it difficult to intercept the communication, it's even difficult to determine that there is communication taking place, especially when that switching is occurring very, very rapidly, like it does with Bluetooth. Of course, the military would be using this over a much longer distance and higher powers and so forth. But the idea of switching channels very rapidly makes for a very secure channel, and therefore obviously attractive to the military. So just a little bit of insight into some ideas of Bluetooth, and I hope you enjoyed this edition of Mark's Tech Talk, and stay tuned for more.